anymore. So we're just going to go straight into it. Apparently Philip doesn't actually know what I do. Ops is this weird mixture of sysadmin, network engineer, and systems engineer. Basically, you do everything. Okay, next slide. This is our glorious infrastructure. It definitely does not go burr. The servers run extremely hot. They're nice, they're toasty, they're all comfy, they got their little blanket. OpenStack, sometimes it goes vroom, sometimes it gives you a 404. You never really know. And we don't really run any cool websites on the infra. If anyone wants to show me one, that's cool. But we definitely don't run any game servers on it. That definitely has never happened. There's definitely not a Minecraft server turned on right now. All right, next slide. In all seriousness, the reason we have the infra is primarily for competitions. So hopefully you've all heard of ISTS. It's pretty cool. It's pretty fun. Red team loves it. Blue team loves it. Black team secretly hates it. But in all seriousness, using OpenStack to deploy ISTS makes it so easy. At this point, we've gotten it down to, I think we can basically deploy it in only a couple of hours. Basically hit enter on a couple of programs and you're good to go. Just don't tell Red Team that. They like their week to deploy. The other thing we do with it is research. We have a couple hundred cores and 2 terabytes of RAM. So you can basically do whatever you want on it. As long as it's not a honeypot, don't run honeypots on it because ITS will get salty with us, and I like having a good relationship with ITS. And also, like I said earlier, random stuff. If you definitely don't want to run a video game server on it, you can definitely not do that. Next slide. So back to the competitions again. We run Terraform, which does all of the low-level stuff. So takes your base image, say an Ubuntu VM, it puts it somewhere, puts it on a network, creates the network, creates the router for the network, and make sure it has an IP so that we can then run Ansible against it, which will put all the services on that VM that you might want so that you can then score it. And again, you basically just run Terraform and then Ansible, and you have a competition. And then the pictures on the side, the top right one, that is our glorious management network, I think. Actually, it's 2 networks, I think. And the one below it is what happens when you have networks but no routers. Next slide. So this is a bunch of orange lines on a not black background. Specifically, this is, in theory, how to set up a project, which is basically your account, so that you can deploy instances. We will have a demo of how you actually do this next, or 2 slides from now. Also, Philip, you have to hit the right arrow a bunch of times, I think. Yeah, there we go. Now we have all our glorious orange lines. I will go into more detail on this 2 slides from now because we'll have a live demo. And I'm not really going to go into this because OpenStack is stupid complicated. But the biggest thing to know about OpenStack specifically is, unlike, say, ESXi or Hyper-V or Workstation on your laptop, OpenStack doesn't actually do any virtualization. In fact, it really doesn't do a lot of anything. OpenStack really is just a bunch of APIs that manages other things. Because, for example, OpenStack could actually be VMware. It could be vCenter and all your fancy stuff. So, all the people that have used RLIS at RIT or anything like that, OpenStack could actually run on top of that. OpenStack could be what you use to manage all of that infrastructure. In our case, we use Linux because it actually supports old hardware. And if you were to go back a bunch of slides, you might notice that the servers that we have are quite old. Well, you went way too far back. Minus those two desktops. Those two desktops are clearly new because they have fancy RGB. And of course, everything needs RGB these days. But yes, those servers are very old and they straight up don't run ESXi anymore. So instead, we use Linux with KVM, which means it basically just supports really, really old hardware. And yet we do have our hardware old enough that even Linux doesn't support it anymore. Okay, so apparently I'm doing a demo. I don't know how I'm doing the demo because I don't have control over the screen sharing shenanigans.
You should be able to share the screen now. I do this. I don't know how to do it. I was gonna put the thing up, but no. Yeah. So you should be able to share your screen, Kyle, now, I think, yeah? I shouldn't be muted. You should be able to share your screen now, Kyle, I'm pretty sure.
This is true.
There we go.
Okay, so I would like to point out everything about this presentation has had zero practice, and I didn't write the slides. Also, I haven't tested any of the demo, so maybe it'll work, maybe it won't. Who knows?
Before you do the demo real quick, there is a quick question in the Twitch chat, and that is, why do we use Terraform over any of its alternatives?
So I'm going to be honest with you. What is an alternative to Terraform? So for context, while we wait for that, Terraform is decently unique in what it's designed to do, which is specifically to deploy instances in clouds. So it isn't a a configuration management tool. It only makes sure something exists in the cloud. So it makes sure you deployed your Ubuntu VM. It makes sure that the network's there. It makes sure it has a public IP. But it won't make sure that that instance is running a database or a website or something like that. So we use Terraform because that's really all there is that I know of off the top of my head. Now, the better question is, why do we use Ansible? Because there are a lot of alternatives to Ansible. For instance, Chef is one alternative. And the main reason we use Ansible is because that's what we started off using with. And I don't know the exact reason why we started with Ansible. But the other reason is all the alternatives put an agent on the host being the VM. And Ansible doesn't do that. Yes, Ansible leaves lots of stuff behind, and it's kind of disgusting in that regard. But it doesn't leave a running service. It only leaves some temporary files. So that's the main reason why we use Ansible. It just doesn't leave anything running on the host once it's done. And it also can work on basically anything that can have SSH or WinRM on it. All right. I hope that answers your question. So let me just move this over there. I'll go over the demo in the form of the slide that I didn't really talk about, except we're not going to do it from Dan's project. We're going to do it from this glorious name that I have here. So the first thing you need to do is you would go down and you'd be like, hey, admin, I need a user in a project. And the user, the admin would go create a project, throw in a name, cool name here, and then they'd hit create project. Then they'd hit create. Then they'd go to the users, create a user, put in all this fun information, make sure you put the correct project in. But we're not actually going to do this because this project is set up so we can do some fun stuff. So then the next step would be create a network. So we go here and we'll give it a fun name. Fun name. I think I have admin perms in this project, so you wouldn't actually see all of this, but you would definitely get some of it. We'll throw in the subnet name. And then one of the cool things you can do with this, which depending on your level of fanciness with VMware, for example, if any of you have interacted with the cyber range, they use NSX with vRealize, which, long story short, is very expensive, very fancy stuff that makes it so networks will overlap with each other, which means if I went like this, that would be a problem, because if it attached to anything else in the infrastructure, it would conflict. But because OpenStack has this concept of projects, what I do in this project has no impact on anyone else's projects. So I can do something like a 10/8, which in theory would conflict with a lot of different people. But because this is unique to my project, it won't conflict with anything. I can enable DHCP and all this fun stuff. I hit create. And now I have this big giant subnet here. So then we go into routers. We create a new router. And then we select the external network, which the only one we have right now is the RIT WAN. And it goes nice and slow. And then we have a router. And we go back to the network. I think this is the right step. Actually, no, I lied. We do it from the router. So we go here. And we add an interface. Oh, in other fun news, you'll notice we have HA, which is great because that means when our nice and old servers fall over, everything will still run. And if you're on an SSH connection or something like that, it won't even drop the SSH connection.
Hey Kyle, what's HA?
High availability, which means when the server explodes in the rack, things still keep running. All right, so we're going to go to instances. And we'll just launch one instance for now. But you'll notice here, I could just, add a couple zeros here. Okay, I added too many zeros. And just hit enter, and I'll have 100 of this, not just one. We'll go here, we'll say 10 gigs, and then look at all these glorious images. We'll use the best image, though, our temporary image that's existed for half a year now. We'll give it some RAM. By the way, these are very similar to if you were using any public cloud, think AWS, GCP, Azure. We'll give it our new network. And then we'll put a security group on it. Oh, we don't have any security groups. We'll go through our, put a SSH key on there. And then we'll hit launch. And then in a couple seconds, our VM will be up. I hear a lot of you like to complain about a specific grad class that uses a specific infrastructure that takes like half an hour to deploy 2 VMs. I'll have you know you don't have to worry about that here because it's now up. And then I associate a floating IP with it. Oh no, I don't have any. So I click the plus and then I click a locate IP, associate. Then I open up my terminal, which you can't see right now. And then I can say SSH to this glorious IP. Unlike the fancy clouds, there is no copy IP, which kind of sucks. And then how do I change screens that I'm sharing? How does this work? I don't. I'm confused. How does this work? Maybe you don't get to see, but I successfully SSH'd into my VM in like a couple of seconds.
Yeah, you need to just stop sharing and reshare the other screen.
Okay, that's kind of lame. I think most of us have seen an SSH connection.
Yeah, what's SSH, Kyle?
Well, I hear, I think we probably went over that in education, probably in one of the first couple of weeks last semester. So should hit up our YouTube and it'll be there. All right, but that's lame. Let's have some fun because again, we're shitting on our list and whatever the other cloud provider thing RIT has. Let's see, lots and lots. And we'll just add a couple zeros. Apparently a bunch of stuff got deployed last night, so this might not work. This is the only thing I actually did test. In other news, the ISTS Windows 10 image is definitely messed up right now. So we're not going to deploy that because that will make infra sad. We'll give it the sane Windows image, and we'll use not my subnet because that subnet's disgusting. We'll hit launch, and maybe this will work, or maybe this won't work. Who knows? And we'll just quickly open that. Or more specifically, we won't quickly open it. We will slowly open it. Very, very slowly open it. See, if I opened 100 Calibri instances, that would be boring. Like they wouldn't like murder the disk or anything. We want to see fancy graphs of things getting sad. Damn, I'm a liar. This is going slow. Apparently I broke the infra. While we sit here, let's look at some fancy graphs. This is the infra getting sad, as I told it to make lots of stuff. Do we have? No. Oh, look at this. We're spawning now.
Who would think that 100 Windows VMs being deployed all at once would make Openstack slightly slow?
Okay, so question in Twitch. since we already have the OS on standby, all you had to do was configure the network. So we're going to get a little deep here. That's not quite how it works. So you build the VM, but you kind of build the VM in a way that it's very unconfigured. It's called sysprepping specifically for Windows, which means anything that would be unique to that VM or that machine is removed. So on initial boot, there actually is a bunch of configuration to do on the VM itself. But for the most part, it is just turning the VM on and it getting DHCP. There's another part of the secret sauce, which is Cloud Init, which allows you to do some configuration on initial boot. That's how host name gets set. That makes sure the disk, because you saw that I changed the disk from 20 gigs to 25 gigs, that makes sure that auto gets changed. So we, as you see here now, they've all been built and they're all running, and it took us 2 minutes. And we have Windows booting. So these Windows images have been kind of messed with a lot in the past 6 months. Back in the day when I initially did my testing, we could deploy 100 Windows instances and they'd be booted within 5 minutes. I don't know for sure if we're going to succeed at that, but considering it's only been 2 minutes, we might. And while we're doing that, we can look at some more graphs. Turns out when you deploy about 100 Windows instances, you start using a lot of CPU. And here's our nice total amount of RAM. We're pushing a solid 2 gigabytes of data right now. It's not that much, but solid 20 gigabit of bandwidth. We're still getting Windows Server ready. So part of the reason actually that booting Windows takes as long as it does is, like I said earlier, this whole sysprep system. Oh God, Dan told me to check the network topo. That's going to be terrifying. But sysprepping makes it so Windows has to do a bunch of stuff on the initial boot, which can slow it down quite a bit. Has to generate a bunch of unique IDs, and the info we're deploying to is slightly different than where we built the image. So Windows will do some driver shenanigans and all sorts of weird stuff.
Question, Kyle, because
Yeah.
you said about the network flow. How much do we see like during competitions usually? Like right now we have like 2 gigs about. How much do we see during comp?
When was ISTS? We can look. Was it in March 7th?
Yeah, fifth and sixth. Six would be the best option.
Okay. Whoa, whoa, whoa. Maybe we'll just do this. We'll just do the whole thing. You want some network? So I can tell you when we deployed stuff. Look at that. We're not even at 100%. We're not even at deploy 100 Windows instances level. It's tiny. So this is specifically storage, by the way. Our storage is over the network. It's not local. That's part of the reason why we can deploy 100 Windows instances and it not immediately fall over, because we can kind of cheat when it comes to storage. Oh God. Okay. So this is the actual like network traffic, which really isn't a lot. Also, reminder, this is megabytes, not bits. So multiply everything you see here by 8 for your normal network traffic. But again, it's really almost nothing. But what you will see is we do use a bunch of CPU here.
I've gotten word.
Most of this,
Sorry to interrupt.
sorry.
I've gotten word from Dan that he just deployed 100 more Windows VMs. Yeah. Oh, not Windows. What VMs, Dan? 100 more Calibris have been deployed. That's all.
Uh, what project? This project? Oh, by the way, oh, yep, see, Windows Server does have to restart because the host name gets changed. So I can tell you officially that this is definitely not 2 minutes. It's been more than 2 minutes. So it does take more than it used to, apparently. That's kind of depressing. But it takes under 10 minutes to get it fully deployed and configured. Oh, there you go. Yep, there you go. There's another 100 instances.
Oh, can we look at that network topo at some point?
Okay. Yes, we can. Wow. See, Calibri took less than 4 minutes to deploy. All right, network topology. Huh. Seems like we have a lot of VMs.
They're calling for GraphQL.
Oh, you guys want some graphs? I can get you some graphs. This is nothing. All right, hold on while I log in on a different screen. We can get some real ops graphs, none of this CA graph stuff. Maybe. Or maybe I'll get disconnected.
Check Twitch chat, says John Bauer.
Twitch chat? You would ask the ops lead for an account, like I mentioned earlier. And they would provision you with a user in a project, and you could deploy some VMs and stuff. But we're going to go over here now, and we're going to look at the fancy graphs. None of this boring, where is it? None of this boring Openstack graphs. We'll just go over here. We'll go to Fast Nova. This is one of our newest servers. Ignore these things flying around. I don't know what they're doing. They're just, little unique snowflakes. And now we have this very laggy graph that shows us every single instance on this host and all of its network adapters. And it shows us how much bandwidth is being used by every single VM. So we can go over here and we can be like, what host is this? Somewhere, maybe. Maybe I'm not a liar. Somewhere it'll say what the name is. Somewhere. Maybe it won't. Maybe I'm a liar. Apparently I'm a liar. Wow. Okay. Tells you how much I know. In theory, we would have every single host name of every single VM. And okay, we can see the network name. Okay, whatever. This is our glorious graph, though, of every single instance and all of the bandwidth being used. And we could capture the traffic of any individual instance if we wanted to, which is a lot of fun. Do we have any more questions? Does Dan want to hop on? I heard he wanted to hop on earlier.
Doesn't know what to say. He's camera shy. Is the camera even on me? I don't think so. Kyle, what's the chances of next year ISTS cost being a /8 instead of a /16? I think we need an upgrade in the amount of networks.
See, we can't give Koth a /8 because Red Team wants the /8. So Koth would have to probably play some Halo against Red Team to see if they got to
Oh,
have a
I'm
/8.
pretty confident Koss can get that /8. Yeah,
All right.
it'll be fine. Koth is a fun time. You should do Koth if you compete in ISTS.
I hear most of the time the teams that win do Koth. If we want more graphs, let's have another graph. This is our this is one of the storage nodes graphs. You can see deploying Windows uses a little bit of our storage, also known as 100% of it, which is kind of depressing.
Kyle, did you see John's question about what do I do if I want to use this for my own personal projects? You did? Okay.
Yes, I did. I can answer it a third time, though. I have no problems with that.
More answers. I think you should answer it a third time because this is actually about the 50th time you've answered it, and I don't see very many people using it for personal projects when I log into Openstack.
That is pretty true. You know, there's like 3 people that host video game servers, and that's about it. It's pretty depressing.
What I can do on OpenStack. Like, can I just do? Is it just give me an instance and I can do whatever I want, host whatever I want on there, or just?
I mean,
I'll make a few websites if that's possible. I'd like that.
So what Philip said very quietly is, uh, what can he host on it? Which again is pretty much anything as long as it doesn't break the rules of RIT. Also, no mining crypto coins. Screw that.
that also breaks the rules of RIT, so you got
Okay.
that covered. But
There you go. So if you want your own account, you want to do stuff, you be like, hey, Obsolete, can I do this? And if you don't know who the Obsolete is, you could either go to our website, or you could just look at Discord. And most people in ops have a little ops role, and they would know who to point you to get an account. But then they would go, they'd hit create project, they'd type in a cool name for the project, also known as your name, and then project members, and then they'd go to users, and they'd create your user, and then you'd be good to go.
yeah, you also have to make sure that the user has access to the project and all of that fun jazz. But
Well, fun fact, when you're just a normal person and not a CA, all you need to do is go to the primary project and be like, boom, primary project, team 1,
yeah,
and then you're good to go.
I'd say OpenStack is a very, very useful tool to use. I've used it for homework many times. It's much easier to get files to and from than, say, an RLS would be. And unless you're like needing the RLS infrastructure for files hosted in a particular VM image, then would highly recommend considering this option. It's very convenient.
Computer, laptop, because you're cool.
Imagine doing that and taking up all your own resources when you could have an entire cloud.
When you could literally have terabytes of RAM and hundreds of cores.
Yeah, if you're doing something like on AWS, though, like just put it on OpenStack.
More or less, yeah.
Look at this. We're using 845 cores, and we only have 384. Like, and we definitely have 366 terabytes of disk storage, and we're definitely using 0 bytes with our 200 VMs we just deployed.
Sounds legit.
This is very accurate.
Highly accurate lies reported by OpenStack.
Well, the left 2 things are actually correct. We are actually using 845 cores out of 384.
Yeah, Kyle, what is closed stack?
See, I don't know what closed stack is. I've only been in charge of OpenStack, but I hear there was a closed stack before my time. I also hear there's a shirt that says senior closed stack engineer on it, but not sure about how true that is.
That sounds like an urban legend.
Yep.
There was one that custom
Definitely don't go on Custom Ink. There definitely isn't a shirt with that name on the back of it on Custom Ink.
Alright, I think that wraps up OpenStack talk. There's no more questions. Yeah? I don't think there's any questions, is there? Yeah. Thanks, Kyle. Is this your first presentation, Kyle? Do you need a lanyard shipped to you?
No, I've done like 3 or 4 presentations.
Gotcha. Yeah, then you need like a lockpick section.
This actually might be my first presentation since we've gotten the new lanyards, though.